solve the compound inequality. We have a inequality here, x over 2 plus 3 greater than negative 2, and we have another inequality, 4 minus x greater than 4, and we would like to find the x values that either satisfy this or satisfy that, or that satisfy both, right? Or means one or the other or both. So why don't we go ahead and solve this inequality, and then we'll solve this, and then we'll go ahead and take a union of those two answers, and that'll tell us what's here or there. So for this one, since I have a denominator, why don't we start by getting rid of that denominator? I'll multiply both sides by 2. So I multiply on the left by 2, and I'll multiply on the right by 2. Over on the left, 2 times x over 2, the 2's cancel, I'm left with an x. 2 times 3 gives me a 6. This is greater than negative 2 times 2, negative 4. Right? I multiplied by a positive 2, so I didn't have to change directions of the inequality. Even though on this side there's a negative result of that multiplication, but I didn't multiply by a negative number, so I don't have to change directions of the inequality. Let's go ahead and subtract 6 from both sides, and we get x greater than minus 4 minus 6 is minus 10. So x greater than minus 10 is what we get from this piece. Let's look at this other piece. Let's go ahead and subtract 4 from both sides. So I get negative x greater than 0. Let's get rid of that negative sign. So let's multiply both sides by a negative 1. Negative x times negative 1 is x. 0 times negative 1 is 0. I've multiplied or divided by a negative number, so I have to switch the direction of my inequality. So here is the other part of the inequality. So I want to be here or there. So these are all the x values that are less than 0 or that are greater than negative 10. Right, let's graph that on a number line so we can clearly see what's going on. Here's 0. X is less than 0, are all those, not including that point. The other interval, x greater than negative 10, here's negative 10. X greater than that, that's all those, not including that endpoint. Or, I want to be in the orange or in the purple. So we look at any point on this number line and we ask, is it either purple or orange? The answer to that's yes. If I'm here, I'm orange. If I'm here, I'm both orange and purple. If I'm here, I'm purple. If I'm in this open dot, which is not purple, it still is orange, so we get to include that. If I'm in this orange dot, it's not orange, but it is colored with purple, so I get to include that. So I get to include all the x values. So this union, this union of this interval and that interval is everything, minus infinity up to infinity. As always, we do not get to include negative infinity or infinity as our endpoints. Those aren't real numbers, right? But everything else is in there.